Okay, so good evening. My name is Nilmoni Karak. I am a research scholar at IIT Kharagpur. So yeah, today I will discuss some basic problems which are needed, maybe needed in this course. Okay, okay. So Ravi, this is visible, right?
Yes, sir.
Okay,
It is
okay.
visible. Very nice.
Okay, so like the course name is Fourier Analysis and its application, right?
Mm.
Fourier Analysis and its applications. Okay, so like there are lots of story when this Fourier series came. Okay, so uh, so you can see the lectures video and you will get some story for first lecture video. Sorry, in first lecture video there are lots of stories. Okay, so mainly the Fourier series, like f is basically 2 pi periodic function, and if r to r. Okay,
Yes.
and your this is piecewise continuous. Okay, so like this is like the Fourier series expansion is a naught plus n equals to 1 to infinity n cos nx plus bn sin nx. Okay, okay, so let me write one question, simple question. So maybe like it is needed. So the set of all continuous function on 0 1. uh, Actually sometimes this is called C01, right? So you know about this function C01?
That means
Not
you are
function, this
saying
is set, this is sets actually. So you collect all the sets, uh, so C, so write these f 01 to uh, R or C. Okay,
Mhm.
and f is continuous. So this is a set of all continuous function on 0 1. Okay,
Okay.
so my question is this C01 is Banach space under Supnum, uh, is Hilbert space under Supnum is a Banach space under Eltonum is a Hilbert space. Wait. Space
That
under.
is a assignment question.
Yeah, actually, this is like assignment zero question, right?
Zero, zero.
Yeah, yeah, yeah. So this will be not evaluated, right? This will
Correct.
not be evaluated, yeah.
Yeah, can we discuss this?
Yes, yes, yes. That's why I can discuss this.
Yes.
Hi, Mridula. So, hello. Oh, so she left. Okay. Okay, actually, I think you know Banach space, Hilbert space, the definition of Banach space.
Not exactly
Actually,
actually, because
yeah.
these terms I not heard
Okay,
these
so
spaces. You can explain what is the different types of spaces.
yes, yes, yes. But first of all, yeah, Banach space. So non-linear space, you know, or
Pardon?
metric space,
Huh?
non-linear space, vector space.
Vector space, yes, or vector spaces, yes. Vectors span a space, span a plane, two vectors, three vectors span a space.
Yeah. So
So, linear combination of them create a space.
okay.
Linear combination of two vectors creates a plane
Yeah, yeah,
if they
yeah.
have
That is true.
a common point.
Okay, so I am defining Banach space. Okay, so Banach space. So basically, a Banach space is a normed vector space X over. So vector space should be over field R or C. Okay, the coefficient comes from field, right? That
Yeah.
is complete with respect to, like, induced by its, so with respect to metric, sorry, metric induced by its norm.
So you're saying
So
norm.
actually, complete means, so you are taking a Cauchy sequence from X, and which will be converged in X only.
Mm,
So that is called complete. So R is complete, right?
yeah.
So R,
See, the field you mean it is a
yeah,
field.
yeah. R, this is like, is a complete norm vector space.
Mm. So when you say norm vector space, it is a magnitude is all one. That is what all vectors will have magnitude of one.
Magnitude means, what do you
A
mean by?
vector size, if you take some vector A, absolute mod of A is the norm, or length of the vector. Is that unity? If it is unity, you call it a norm, or what is norm?
Not norm is like, is general thing here. Okay, so here, so first of all, dxy. So in for R, this is just mod of x minus y. Okay,
Okay,
and
differential,
here norm means x minus y. So so
absolute value.
yes, absolute value, right? Difference.
Yeah, that is same as length.
Yeah, length
Length.
in R, this is length, but
Uh,
when you study some general case, like in a topological space or in a metric space, then
mm,
always you cannot measure the length, right? In
mm,
R2 you cannot measure the length. like so in that case in R2,
You can compute the length, right?
yeah. So for this you have to not always this difference is this difference form a metric. Okay. So actually if you know metric space, then it will be easy to understand.
Mm.
Okay, so now you assume this complete norm space means like complete space. Okay, which can be vector space, norm vector space can be metric space. Okay,
Okay.
okay. So
So
and
what is
complete
metric space
and
mean?
complete means completeness. Complete means that. Oh wait.
Somebody is joining.
Uh, no, now not joining. Okay, no problem. Complete means your that every Cauchy sequence in H, not H, so here I'll write X, converges to an element in X. So you know the all the stuff for sequence convergence of sequence. Okay, so
Convergence of sequence, I know.
and Cauchy
Like say
sequence
1
also you
plus
know.
half plus 1 plus half plus 1 by 4 plus 1 by 8 plus 1 by 16. It will converge to 2. That is also convergence of sequence, right?
Yeah, 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 but in
Like sin
general,
x series expansion. If you take, it will converge. X minus x cube by factorial 3 plus x to the power 5.
okay, okay, okay,
So
yeah.
you see, there can be any number of sequences that converge.
No, like you, if you consider
What is
xn
Cauchy
equals to
sequence?
1 by n, okay, this
Hmm.
converges to 0, right?
Yes, as n tends to infinity, it goes to 0.
Yeah, as n tending to infinity.
Hmm.
And but is it Cauchy?
What is Cauchy? I mean, to recollect, could you explain Cauchy?
So Cauchy means so for all a n, get r equals to for certain stage like capital N.
Hmm.
Okay, so the difference xm minus xn, this should be epsilon, and for or every epsilon greater than 0. Okay, so like for
No, only
after a
that is.
certain stage, if you take any two elements xm
Uh,
and xn, the difference should be always less than epsilon, and
oh, great.
for every epsilon greater than 0. So
Yes, got it. And
yes, yes,
epsilon is absolute value, that is small value. However small it may be,
yes, yes,
this will be
yes,
smaller than that.
yes, good,
This difference between two successive values.
yeah, yeah.
That is what is the convergence.
One type of convergence,
One
not
type. That
always
is one.
convergence, but like mostly convergent, mostly it will converge, but in R it is same thing. Cauchy means convergence, convergence mean Cauchy.
So this is called Cauchy
Yes,
convergence.
yes. So that's why when like it is same thing, Cauchy convergence, Cauchy and convergence. Okay, so you need
Both are
completeness.
same actually. Convergence means this only. I mean, as we have studied in engineering also,
Yeah,
this is
convergence
a
means Cauchy. There is no doubt,
oh,
but Cauchy always not like Cauchy means not always convergence. Okay, whenever
hmm,
you are in complete space, so Cauchy means convergence.
okay.
Yeah, the sequence. If you take Cauchy sequence, it will converge, but it will converge. It converges an element either in the set X or outside the set X. If like converges to inside the set, then it is converge, like like it is complete space. Okay, otherwise it is incomplete.
So it is within the system, within the set.
Yeah, in complete space, it is within the set.
So something like field definition, field.
uh, so no, not exactly. So field is different thing, so these are
Okay,
like
okay,
structure.
okay, okay,
Yeah, yeah. Okay, so okay,
okay. I understood.
let me like yeah, yeah, I'll discuss it about
Got a feeling of it. Yeah.
I'll discuss about it, okay, later. Okay.
Metric space also you can explain briefly. What do you mean
So
by
metric
metric
space,
space?
like yeah. So so
Yeah, first terminology I want to understand, but when you explain, I
sorry,
got it. Mm,
sorry, just you have to take a non-empty set
mm,
M.
mm,
Okay, and then MD is called a metric space if uh, so if the following satisfied,
mm.
some axioms should be satisfied. Okay,
Okay.
so okay, and dxy equals to dyx, triangle inequality last, sorry, dxy plus dyz. So for all x y z,
Mm.
sorry, not m. Okay, these three properties should be like follow.
Mm.
Okay,
Distance property.
yeah, distance property, yes,
This is a distance property.
yes,
All the
yes,
three
yes, yes, yes.
axioms.
Hmm. Now you got little bit, right?
Yeah, this distance property is very clear to me. So that you call it metric space.
Yes, yes,
Great.
yeah.
Yeah, yeah. Very clear.
Okay, now like we should come back to our
And these are
problem.
all nomenclature, though they are familiar earlier,
Okay,
these
okay.
words may not have used.
Uh, well, now also we can discuss Hilbert space. So in
Mm,
question is it is there.
mm.
Okay, so Hilbert space, a Hilbert space, Hilbert space is a,
You will all later you will upload all these notes, right?
yes, yes, of course,
Great.
complex inner product space. So inner product space, you know,
Yes, dot product, no inner product. Say
yeah,
two vectors are there, a dot a and b. A dot b is inner product.
yeah.
That space, that all that a dot bi is
Hmm.
inner product space. Two vectors.
With respect to norm induced by the inner product space. Okay, so norm here, norm is like this, x
Mm,
comma x.
mm.
Okay, and x comes from h. Okay, and here also this space, like if this is
So yeah,
complete.
this is inner product of x with itself.
Yes, yes. Actually, we are like saying the Hilbert space is like a inner product space which is complete. Okay, and
Mm.
norm is like this. Okay.
Okay.
Okay. Okay, now we come back to our problem. So we are like checking this C01, this space is a Banach space under Supnom, Hilbert space under Supnom, Banach space under L2 norm, and Hilbert space under L2 norm. So we should we should have clarity about this norm. So Supnom, so Supnom is basically this norm sup x belongs to 0 1 mod of fx. This is called sup norm, and L2 norm, L2 norm is basically so 0 to
See, what
1
is sup here? SUP. SUP
supremum
means
supremum.
supremum. You take
Yes,
supremum means
yes, yes.
maximum value.
Not exactly maximum. So there are some differences in between. Okay, so
Detecting.
supremum is like uh, maybe in set or not, but maximum should be in set. Okay,
So outcome will be in set.
like if you consider the set 1 by n, right?
Hmm.
So here infimum and supremum concept is like so 0 is infimum and 1 is supremum, right? 1 is in set, so 1 you can say this is supremum as well as maximum, but 0 is infimum but not minimum.
Hmm.
Got it?
Okay.
Yeah.
How is zero infimum? I mean,
uh,
it approaches zero
so yeah is at
as it
so
tends to infinity.
yes, sorry, yeah. Some
One
code.
by n.
Yeah. So,
Example.
haha, yeah, one by n actually. So, these are like you if you check so infimum and supremum definition, you can easily understand.
Okay, I will check.
Okay, yeah. So you like you can study some basic real analysis, then
Okay, okay, okay.
yeah. Okay.
Sure.
Yeah, so these two norms we have to check whether the C01, the space C01 uh, is complete or not. So, okay, so also one thing note, every Hilbert space is a Banach space, but not every Banach space is a Hilbert space. So the counter example we will give. So yeah, so for this problem only, this problem is only like is an counter example of this statement. Okay, and also one thing, so that's why you need some function analysis, basic function analysis.
That means Hilbert space is subset of Banach space.
Uh,
Can you say that?
yes.
Okay.
Hilbert space is more specific, right?
Ah,
So Banach space is like any complete non-linear space, but
logic.
Hilbert complete non-linear space, non-vector space.
Hmm.
But Hilbert space, like for Hilbert space, you need some specific norm, which is inner
Hmm.
product, which comes from inner product.
Hmm. Hmm.
O-
Okay.
Okay, that's why
Specific
Hilbert space like
subset.
yes,
Subset of the
you are
operations.
right, you're right.
Yeah,
Not
whatever sentence you have written is described by
yeah.
this
But not vice versa. Okay, so
Yeah, I understood.
Yeah,
Because you have put right side, no, Banach space.
yeah.
Subset means line also you are there or line will not be there.
Maybe there,
Some
because
sometimes Hilbert space can be equal to Banach space.
yes.
Okay.
Hmm. And okay, so and now also one property, mm, if H is a Hilbert space, if and only if it holds parallelogram law. What is parallelogram law?
Yeah,
Ex-
it is a law of vector addition.
exactly.
Where two vectors are added, diagonal represents the sum of the two vectors of a
Yes.
parallelogram. If the sides are the vectors.
Yeah. Okay. So now we will see C01, the subnorm with respect to subnorm is not complete. Is not complete. So why? So to show not complete, so we will take a Cauchy sequence. Okay, we will take a Cauchy sequence which will converge to an element which is in the in C01. Okay, so yeah, so Fn like we are taking like this, so Fn equals to 0 when 0 less equals to x less equals to half minus 1 by n, and n by 2 x minus half plus 1 by n. So you can draw also this graph and to clear for for getting clear visualization, and half plus 1 by n and 1 half plus 1 by n less equals to x less equals to 1. Okay, and so I'm claiming like so this you can find this fm minus fn uh, under the subnorm. This is epsilon, and for all mn greater equals to n, and for every epsilon greater than 0. So this is Cauchy. Okay, you can check it. And
One doubt, can I ask
yes,
here what is subnorm? How do you
yeah,
find
subnorm I just already defined, right? This is supremum.
supremum? Okay,
Yeah,
means
supremum of
maximum
absolute.
value,
So
even if it is outside the set, you will take, right? Supremum, or only within
yeah,
the set?
yeah.
Huh?
Not
Within the
within
set,
the set, like always not with.
even if it is outside set, also you can take.
Yes. Supremum means like just you can find like this the like so you know lower bound upper bound.
Yes,
Supremum means your
upper bound,
smallest upper bound. Okay,
smallest upper bound. Okay,
okay.
okay,
It may be lies on the set or not. Okay,
okay.
okay. And infimum is like a different thing, opposite thing. So infimum is largest lower bound.
Okay,
Yeah.
got it.
Hmm. Okay. So this Fn converges to F actually, and where fx is fx is 0 when x less equals to half, 1 x greater equals to, sorry, x greater than half. Okay, this is not continuous. And how to show, uh, okay, one thing, I just I did mistake. Okay, so no, so I wanted to show actually this norm is not complete. Not actually infinity norm is should be complete. Okay, so yeah, mistakenly I have written, and this also you can find. And okay, so one thing, fn minus norm 2, I just have written, right? What is norm 2? L2 norm. Okay, so integration 0 to 1 mod fx square dx, and this whole to the power half. Okay,
Mm.
and
Okay.
this is actually goes to 0, you can check. Okay, and okay, so but f is not in C01.
Say one thing, you are defining in terms of integration, right?
Yes, yes, yes.
Integral. Uh,
Yeah, yeah. Actually, I am not even. I am not like computing. So you
no,
can
I
compute.
understand. Even if we don't compute, go back to that integral formula, what you have given.
Uh,
Integral
Here.
fx mod fx whole square
Yeah,
dx
yeah, yeah,
0 to 1.
yeah,
That means if we have a curve like y equal to mod fx curve and square it, that graph
yeah,
between 0 to 1, whatever is the area under that curve,
yeah.
then should be the value of this f, right? Norm 2.
Yes, yes, yes.
Integral you can define as an area under this curve y equal to fx square.
Yes, yes. That is
So
different thing.
between
Yeah.
0 and
So
1, that area you are saying will be 0?
not exactly. Where 0? Uh,
No, below you have written 0, no? It approaches 0
so
now.
see,
Fn
by
minus.
in like whenever you are like integrating some function, so maybe like not you are getting always area, right? So maybe you are
No,
getting
but it is a
volume.
squared function, square of absolute value. So it
Oh,
is always a positive side only, it will be there. So
yeah,
that can never be 0 if there is a shape,
yeah,
curve,
yeah, yeah,
anywhere.
yeah,
It
yeah.
will have some area.
Okay,
If it is not squared, then whatever you are telling, like sin x graph, if you take
yeah,
minus pi but 0 to 2 pi, it will be 0. Integral sin x dx.
okay.
Whereas sin square x dx, if you take, it will not be 0. It will be value will be there because the lower side will come upside because you are
No,
squaring it.
actually here only like I'm talking about convergency. Yeah.
Hmm.
So so yeah,
Okay.
your point is good. Okay, I understand. But here, so just we are taking a function fn, so not sequence of function, not only function, a sequence of
Okay.
function.
Okay. Sequences of functions.
Yeah.
Yes. So successive values, the difference.
mm, just 1 second. Okay, I just I
Yeah,
have to
please.
take urgent. Oh yeah.
Yeah,
Yeah,
please.
yeah. হ্যালো, আরে আমি তো এখন পড়াচ্ছি, পড়াচ্ছি এখন। তো তুই যা না, তো কর না একটু, আমি এখন কি করে যাব? আরে তুই কিছু একটা গাড়ি ফাড়ি করে যা, আর সবাইকে বল না পাশের ঘরের। হ্যালো, ওকে, সরি, ইয়া, ওকে, f is not in C01. Okay, so here from these like we are saying sorry, this C01 with respect to norm 2 is not complete. So hi Anjali, uh, hello, can you hear me? Yeah, so no, just I wanted to introduce with you. Okay, actually so I need to know your background. Okay, can you like open your mic?
Hello.
Yeah, yeah. So
Yes, sir. I am a first year student, master's.
okay, and so your BSc is in mathematics.
Yes, sir.
Okay, then
And we are currently having a Fourier series course going on. So,
okay, okay.
yeah.
Fourier series only or Fourier analysis?
It's analysis, but we are on the series part right now. The analysis hasn't started
Okay,
yet.
okay, got it, got it. No, actually, for this course, you need some basic idea from real analysis and function analysis. So,
So, functional analysis is also going on, and real
yeah,
analysis we are
like
done.
basic thing, like some Hilbert space concept, some Banach space concept. Okay,
Yes,
so
sir.
you know metric space very well, right?
Yes, sir.
Okay, then only. Yeah, actually, Rovi has some problems. So, Rovi is an engineering student, like not student. Now he is an engineer. Okay, so
Yeah,
no
but your
problem, Rovi.
explanation is great.
You can see some basic real analysis. Okay, okay.
Your
So
explanation is great.
no,
Your
actually,
explanation is
Rovi, that
great.
is the main problem is like now here I cannot explain everything. Uh,
Understand. You
so
can give me some reference. I will go through.
yeah, 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 yeah. So
The reference material you can share. I can go through.
yes, 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 yes. You can see Rudin book. Okay, what? I will send you the book. Okay,
Yeah,
or in
please send.
email. Yeah, yeah, yeah,
Yeah, yeah.
yeah.
Email.
So
I will put mail.
so you just assume something and like assuming something like you can see this lecture. Okay, actually
Yeah.
everything I cannot explain here.
Understand. Understand. I understand.
Yeah, yeah,
Please
yeah.
send the reference.
Yes,
Book
yes,
name. You can tell me.
yes, yes.
Put in this one. Write down there. I'll copy in my notepad.
Yeah, 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 yeah. Okay, no problem, Ravi. Okay.
Yeah.
So now and C01 with respect to L2 norm is not complete. Okay, and okay. Also a first question, Anjali. Yeah, this is the question assignment from assignment 0. Okay, we are discussing. So this C01, this is the set of all continuous function and on 01. So this is a Banach space under subnorm, Hilbert space under subnorm, Banach space under L2 norm, and Hilbert space under L2 norm. So like this is not true, L2 norm, and not also Hilbert space. I will see. So I will show, and yeah, not Banach space means not Hilbert space also. Uh, okay, we will see later. And okay, why it is not Hilbert space under subnorm? We will see. So okay, also one thing, Hilbert space. If you have Hilbert space H, so if and only if it holds parallelogram law. Okay, this law, and this law is nothing but this. Okay, okay, and so yeah, so why it is not Hilbert space? You take two function fx equals to 1, this is continuous, right? And gx equals to x, this is also continuous. Okay, 1 Why it is 1? Because I am taking supremum x belongs to 0 1, this mod fx, so fx is everywhere 1, right? So this is 1, and g infinity, this is also the supremum is 1. Okay, and what is f plus g? So this is x plus 1, right? X plus 1, and the supremum is 2. And f minus g, this is actually 1 minus x. What is the supremum? This is 1. Okay. um, yeah, and now for parallelogram law, what is the left side? So this is basically x plus y square and x minus y square. So a plus g square plus f minus g square, sorry, infinity, and equals to 2 time plus square, and here all the values are here. 4 plus this is 1 and equals to 2 into 1 plus 1, so 5 equals to 4. So this is not true, so that's why this space is the space C01, sorry, not infinity, is not a Hilbert space. Okay, because not satisfied parallelogram law. Okay, and for actually that true statement is C01, sorry, this is actually complete, means Banach space. Okay, so how to solve it, like how to check it? uh, I'm so I'm giving like some brief idea. And so this fn, first of all, to show Banach space, like it is complete, to you have to show the completeness property. Okay, complete, this space is complete under this norm. Okay, so you take fn is a Cauchy sequence in like C01 under the subnorm. And so Cauchy means like you have some there exist n greater than 0, not n greater than 0, this n is natural number actually, for every epsilon greater than 0, just you use the definition of Cauchy. Okay, and less than epsilon for all m n greater equals to n. And okay, and from here, like what you will get, pointwise convergency of fnx. So just fixed fix x 0 to 1, so fmx minus fnx, this is nothing but this norm, because of this is supremum norm, right? So supremum should be less equals to, and this is less than epsilon from here, and with same condition, right? So fnx is a Cauchy sequence in R, and you know R is complete. Okay, So so R is complete means what? So every Cauchy sequence is convergent. So this limit into infinity fnx. So you have one fx, and which is in R basically. Okay. And now what you will do now? Yeah. So this is Cauchy, right? Fnx is Cauchy. So supremum also. So yeah. So this is true, right? Hmm. Now just you take m tending to infinity, then for every nm, so you can do that, fnx minus, and yeah, also one thing is whatever you take n or m, so this converges to fx. Okay, so fx, this is uh, so you are taking limit to both sides, so less equals to epsilon, and from here, so for every epsilon greater than 0 it holds, and for every m sorry n greater equals to n. So from here, just so you know the definition of uniformly convergent, right? So if n converges to f uniformly on 0 1. Okay, now one thing, a basic property from real analysis. So this is uniformly, and these all are uh, from like C01 means all are continuous. Each Fn is continuous. Okay, and it converges uniformly to F. Then F is also continuous. Okay, so F is in C01. So finally we are getting Fn minus F goes to 0 as n tending to infinity. So like yeah, you are getting F is in C01. So C01, hence C01 is complete. I think you got it, right? Okay. So this is a Banach space, not Hilbert space, not Hilbert, not Banach space. So this is the only correct option. Okay, and remainings you can check. Uh, okay.
So, but we just checked for the sup norm, right? The infinity norm. We haven't checked for L2 norm.
Yeah. I'm like checking. Okay, L2 norm means I just checked L2 norm. Yeah. So L2 norm, this is not complete. Yeah, I just initially I discussed it. Okay, so you have to construct a a sequence of function fn. Okay, this is Cauchy. So this is Cauchy. Actually, I did not like compute. Okay, you can compute. This is Cauchy, and the if n converges to f, and which is not continuous. Okay, the example is this. This is counter example. Okay, so this is not complete. So that's why not complete means what? So two options are not correct, uh, because for Hilbert space and for Banach space you need completeness, right? So under L2 norm, so that's why these are incorrect. 3 and 4. This is not complete at all with respect to L2. Got it?
Yes, sir.
Yeah. So initially I discussed it. Okay. You can check with this sequence of function and okay. So now I think you studied measure theory, right? Little bit you know measure theory. So
Yes.
yeah. So question 2, which of the following is true? Yeah. Every non-empty open subset of R has positive Lebesgue measure. Every uncountable subset of R has positive Lebesgue measure, and the set of all rationals has positive Lebesgue measure. Okay, the set of all irrationals. Okay, the set of all rationals has positive Lebesgue measure. So do you have any idea how to solve it?
So, how much measure theory is going to be required for this course?
Not too much. Okay, so you know measurable function.
No, sir. Only the Riemann integrals and all has been done.
Okay, no problem. Not too much. Okay, some definitions are required. Okay, how the what is Lebesgue measure, what is measurable function, some convergency property like dominated convergence theorem. Okay, uh, so not too much. Okay, if you want, you can check all the definitions and all the required theorem. So and you can you can have like this. Okay, no problem. So you don't know anything about Lebesgue measure?
No, sir.
Okay, actually Lebesgue measure is basically this is nothing but length, okay, with certain properties. Okay, in R, okay, in R I am saying the length, okay. So in Rn it is volume. Okay, so for first problem, so this is an open subset. Any subset of R, open subset of R, uh, you can it represent with union of open interval, right? This is true.
Yes, sir.
Yeah. So and open interval, non-empty open interval, so which has length positive, because you are taking AB, open interval AB, so so this is non-empty, so A less than B. Okay, so the length is b minus a, right? So that's why it has positive. So yeah, open interval AB has a measure, Lebesgue measure b minus a. Okay, so at least this open subset consists one open interval, and if you if it consists open interval, so the Lebesgue measure should be positive. So that's why this is true. And every uncountable subset of R has positive Lebesgue measure. Actually, R, if you take R is what? Rational union irrational. Okay, and also one thing, the countable set has measure 0. You can prove it, and so let me note it, note down. So a countable set has Lebesgue measure 0. So that's why this is wrong, because rational numbers are countable numbers. So you now just assume whatever I am saying. Okay, so to like prove these things, it will take time. Okay, uh, so, and yeah, irrational. So R has basically every uncountable subset of R has positive Lebesgue measure. Okay, this is actually also true, because no, not true, sorry, not true. um, you know about Cantor set, right? How Cantor set is constructed, Cantor set. So basically Cantor set is, so you take uh, 0 1 interval, 0 1. So in first step you have to remove this part. So actually first, you have to cut into three parts. So 1 by 3, 2 by 3, sorry, 2 by 3, and you have to remove this part first. So next your 0 to 1 by 3, and 2 by 3 to 1. Okay, and again you have to do the same. Okay, so you have to like you have to cut this in three pieces, and also this, and you remove this one. Okay, so measure is in an interval, in measure is nothing but the length of interval. Okay, so in the first case, so you are removing 1 by 3. So what is the length of this? 1 by 3. And in second case you are removing, this is 1 by 9, right? And this is also 1 by 9. So 2 times 1 by 9. And in next step you will remove 4 times 1 by 27, and so on. Okay, so I am counting whatever the length I am removing. Okay, and this is nothing but n equals to 1 to infinity 2 to the power n minus 1 by 3 to the power n. Okay, and this series is nothing but this. And if you calculate with geometric series, with the help of geometric series, you will have 1. This is 1. And what is the total length of interval 0 1? So measure of Cantor set C is, so total length of 0 1, and minus this length I am removing. Okay, so this is 1, so this is 1 minus 1, this is 0. Actually, yeah, Cantor set is uncountable. This is an example. Okay, counter example, Cantor set is uncountable, but it has measure 0. Okay, so that's why this is not true. And the set of all irrational has positive Lebesgue measure. Why this is true? Because R is your Q union Q complement. Okay, and this has measure 0. So if you take, so these are disjoint. If you take measure, sorry here not okay, huh. So measure of R is measure of Q plus measure of Q complement. So this is 0. So this should be infinity, right? If it is infinity, this should be infinity. So that's why this is a positive measure, irrational. Okay. So that's why 4 is true. Okay. I hope it is clear. Okay. And uh, in a matrix, yeah, one basic if you study the matrix space, then what is happening? Q's, wait, why, maybe some okay. So maybe I cannot write here. Okay. mm. Whatever I another tool pages. I'm not only writing, right? I don't want to write. Okay, no problem. Now it is working. Okay, question 3. So in a matrix space, one is, so which are true? Okay, compact subset always closed, closed subset are, okay, always compact closed and bounded subset always compact for compact subset are both closed and bounded. This is easy, right? So which one is true, or maybe which are true? Achha, this is compact, right? Okay. Anjali, do you have any idea?
So the third one is definitely true.
No.
No.
How? Closed and bounded are always true. So always compact. So in metric space, I am saying, not in R. Okay. In R, you can use Hannibal theorem, right?
Yes, sir.
Uh,
So compact will imply closed,
yes,
right?
compact will imply close as well as bounded. So that's why 4 is true.
And the first is also true then.
Yeah. Right. So yeah, that's why actually function analysis is needed. Okay. So to construct, also in metric space is also there, like L infinity, L2, small L infinity space. Okay. If you have started, okay, no problem. So closed subset are always compact? No, because counterexample is R, right? R is closed, open and closed both, but not compact. And so closed and bounded subset are always compact. So this is also R for this R will also work, right? Got it? No, actually, sorry. No, for 3 it will not work, because close and bounded both are needed. Sorry. So that's why, like, for 3, so you have to construct like some special infinite spaces, infinite dimensional spaces, L infinity space, which is closed and bounded but not compact. So L infinity is nothing but okay, and now, so construct this subset En belongs to natural number. Okay, and En is your 0 0 1 0. So 1 in n position. Or each En is L infinity, right? Because such supremum of this is 1. Okay, so less than infinity. So the supernum is, so this is like this space is nonlinear space or metric space under supernum. Okay, so this is 1, and this because supremum is 1, so since norm is finite for every En, so AS is bounded, and from here you can see this is like discrete type set, so it has no limit point at all in outside. Okay, so this is closed. And but why S is not compact?
So how do you show it is closed?
Yeah, because like this is a like this is a discrete type set. So 0 0, so first 1 comma 0 0 0, and also, so and then 0 1 0 0 0. So this has no limit point, right? What is the limit point set for this is, for this set is, this would be 5, right?
So I just know the definition of a limit point. I don't know how to like know whether the set has a limit point or not. So how do you check it?
You don't know the definition of limit point, so
I know the definition, but I don't know how to
how to
check if
check?
this set has a limit point.
See. So first of all, the definition of closed set is the limit point set. If the derived set is the set of all limit points, which should be contained in that set, then only the set is closed. Okay, so here S is closed means the derived set since S derive is in S, and S derive is the set of all limit point in S, but this is actually phi. Why? Because you take any point from S, okay, and take a neighborhood, okay, take like for every neighborhood the intersection should be phi, right, not equals to phi, right? So you can like recall limit point definition.
It was that if you okay, a point from the main space is a limit point of the set if the norm of the difference between any point here and that point from the bigger space is uh,
No, just
not the norm.
for
Okay,
any topology,
in terms of open ball.
you can say, okay, for any topology, like see, so this is your S set, this is X is limit point, or X may be in outside the set, okay, okay, so any delta neighborhood, okay, so for delta greater than 0 neighborhood X delta intersection this set not equals to phi, right? This is the definition.
Yes, sir.
Then only, so if you take any points from this set, okay, so you can have one, so you can construct one delta so that the intersection is phi. Every time you will you will get a delta, okay, so because difference is always like not always like more less than 1, okay, so delta you can construct sometime 1 by n, okay, then the intersection should be phi, okay, for any element, for any point in S. So if so say for like if you take any set sorry any points from S, then you will get a delta neighborhood so that the this neighborhood like intersection with S is phi, okay, so any for any element any points in S, so is not like limit point, and for outside case, so definitely it is not true, okay, because like this is not dense type set, right, this is discrete type set, like how to show this natural number set is closed also, mm, this set is closed or not. Oh, wait a minute, just I maybe urgent call. Okay, wait a minute. কি এখন কি হয়েছে? আরে আমি একটু ক্লাস নিচ্ছি, আমি তো পরে ফোন করছি 9টার দিকে, ঠিক আছে? ওইকে বলে দে, হ্যাঁ হ্যাঁ ওকে সরি, sorry for disturbing. Hi, so this set is closed or not? Oh my god. হ্যালো। হ্যাঁ, আমি একটু ক্লাসে আছি। হ্যাঁ, আমি তো পরে ফোন করছি। ও সরি। হ্যাঁ, হাই, হ্যাঁ, সরি।
So, under what metric are you considering?
Not metric actually. See, yeah, here the metric is infinity. So you are right. Like your point is, yeah, okay, but no, means. But here the like metric is also like counting distance. Okay, so no, I am saying the this n is closed and this is closed. This is not closed actually. For this is closed. Okay, but this has no limit point. This discrete type set. Okay, so basically I am saying so um, so sorry. What where is the set is? All the limit points contains in this set. Okay, because this set contains this type of points. Okay, so you can guess it, and to prove it, so you have to do one by one. Okay, and you can see with this norm, this infinity norm, sup norm. Got it? So you check it. Okay, if you are not able to do, so I will like I will solve it in next class. Okay.
Yes, sir.
Okay. Okay. Yeah. And okay, so mm, and this is not compact. Uh, Actually, you can say by no Cauchy sequence exist. Okay, uh, because for compact only also the every Cauchy sequence has a convergent subsequence. You know the like formula maybe, or know the theorem. Okay, so here also like any subnorm you use subnorm em minus en for any, like sorry, em minus en. Okay. mm, so this is actually uh, always maybe greater than 1. Now, any two points distance is greater equals to 1. Okay, so that's why you can construct like you can choose epsilon which is less than 1. Okay, and so you will not get any Cauchy sequence. Yes, so that's why this is not compact. Okay, there are like many ways to do this, like to solve like to get this is not compact. Okay, this is one easy way. Okay, oh no problem. So and in any standard book, so you will get this compact subsets are both closed and bounded. Okay, bounded is easy. Closed for closed, so you have to construct some like special set maybe. Okay, in any standard book you will get this. Okay, this is standard result. And next I think some problem. Okay, so you know about almost everywhere uniformly convergent. Okay, so no problem. This series sin nx. So so you are going to study Fourier series, right? So you have to know this type of series is convergent or not, or pointwise, uniformly, absolutely. Okay, so converges both absolutely sorry, and uniformly on minus pi to pi. uh, converges only absolutely on pi to pi, converges pointwise almost everywhere pi to pi, and diverges almost everywhere pi to pi. Okay, so this series is converges both absolutely and uniformly, and only absolutely, and pointwise almost everywhere, and diverges almost everywhere. See one thing, for x equals to 0, no, not x equals to 0. X equals to 0, this is convergent.
So
Okay.
maybe pi by 2.
Yeah, pi by pi. N pi by 2 is what?
Then n pi by 2 will be oscillating between -1 and 1.
So minus 1 to the power n. But this is
Yeah, and
convergent.
then divided by then this root n is there.
This is
P
convergent.
series test.
This is convergent
Maybe
by your what test? I forgot.
it,
Uh, like any alternating series, and
yeah.
like the series minus 1 to the power n times n, and n is decreasing, and n goes to 0 as n tends to infinity, the alternating series is convergent. So convergent. Okay, no, actually what I
So
will do.
no, but if you apply, like if you take absolute value and apply P series test,
Okay,
then 1 over n raised to p. If p is less than 1, less than or equal to
correct,
1, then
correct,
the series diverges.
correct, but then like you cannot conclude, right? Because you take absolute value, and this is less equals to this sum 1 by root n.
Yeah.
Okay, but so the bigger series is if the bigger series is
Okay.
convergent, then it will converge. But
Yeah,
so yeah, so you
I
cannot
get.
conclude from here. Okay, so no problem. So you know Dirichlet test, in series of function you have studied. Okay, so where you are doing your masters?
So in Goa University.
Okay, Goa University, ANBN. So this, okay, so when this series is convergent, so there are some sufficient conditions. Okay, so n is monotonically decreasing and goes to 0. Got it? This point, like n is monotonically decreasing and converges to 0, and 2 is point 2 is this bn has bounded partial sum. So the sequence has partial sum, right? The partial sum is convergent if and only if the series is convergent. Okay. Now, so for this series, take an equals to 1 by root 10, and this is decreasing. Easily you can check. This is decreasing, and also n goes to 0 as n tending to infinity, and bn is your sin nx. You choose, and the partial sum is the partial sum k equals to 1 to n sin kx are bounded. But how, so why for each point it is bounded or not? Okay, so How it is bounded, we have to check. Sorry, sin x plus sin 2x plus sin nx. Actually there is a formula. Okay. So it is bounded, I think in lectures video you have seen this type of series, right? So for in the kernel D and T, so this type of series is
Cos was there. Cos
on a side.
cos 2x.
Okay. Same thing is like, okay, no problem. So so you can like sum this in same way, okay, with same way, and bound it, and for each x except x not equals to except, sorry, not equals to, except 0, 2 pi, 4 pi, and so on. Okay. um, okay, so actually in denominator there will be uh, sine theta by 2. Yeah, sine theta by 2. Okay, if you sum this in denominator, there will be like sine theta by 2, and so for 0 this is like undefined, for 2 pi so this will be pi, 4 pi this will be 2 pi, and so on. So that's why bounded for each x except this. Okay, and so we are doing we are studying this series in the interval minus pi to pi. Okay, so this partial sum sin kx is bounded in, sorry, for all x belongs to minus pi to pi minus 0 only, because 0, 2 pi, 4 pi, only 0 is there in this interval. Okay, so now using Dirichlet theorem, this sum sin nx by n root n converges for all x belongs to minus pi to pi. So here I am saying about pointwise convergence. Okay, and so this is see, almost everywhere means, so it converges on a set almost everywhere, means that like it converges every point except a major zero set point. So this if this set would be finite or countable, so we don't have any problem for almost everywhere. Okay, this also you will get in measure theory. Okay, so so this like this series is convergent for all x in minus pi to pi except 0. So that's why we call this series is this series converges almost everywhere. So pointwise, of course, pointwise almost everywhere is minus pi to pi. Okay, and diverges almost everywhere minus pi to pi. No, only at 0 x equals to 0 it diverges. So this is not true. And yeah, for these, okay, see, so not uniformly, because not absolutely also. So because 0, 0 no, yeah, because 0 is the problematic. Okay, so at one problem, so at one point this series is converged. So this is not true, but how to conclude this? Yeah, this is not absolutely, maybe conditionally. Okay.
So the Dirichlet test gives you uniform convergence, right? Or was it point-wise?
I think point wise. Uh, like, did you check it? Did you check it? I think it should
I
be
think
point wise.
Abel's and Dirichlet was for uniform convergence of product of two
Okay,
series involving product of two sequences.
okay, okay, okay. And
So
actually I forgot, really forgot. Dirichlet test for uniform convergence, right? Uh, Uniform convergence. Yeah, you are right. Maybe you are right. The condition not converge uniformly in a domain. Yes, Google is saying. Okay. Then also good. Okay. Point wise. This is also true. Okay, for Dirichlet test, because uniformly always implies point wise. No problem at all. And this is not true because here on whole minus pi to pi, whole interval minus pi to pi, this is not convergent. So this is not true. Okay, uniformly. Mm, because for Dirichlet, with Dirichlet test, you are getting this is not convergent at 0. Okay, so this is not true. But how to conclude this is not true? Any idea? So sin nx, it takes the value 0, so that's why it is problematic, right? So to find a lower bound. Hmm. Ravi, any idea? Oh, okay.
Yeah, I think whatever you said is see roughly. If I'm saying, you are saying that at zero it is non-divergent, right?
Yeah, yeah.
Why zero? You get zero value, right? Sine zero is zero.
uh, no, actually, see, so we are dealing with, yeah, sine 0 is 0,
Zero is convergent, no?
and 0 is convergent. Yeah,
Then why
but
we say at zero it is divergent, and so therefore it is almost convergent. Every
yeah,
other point it is convergent except zero. You are saying.
yeah, yeah. I have also noticed. Wait a minute. I mean, yeah. Uh, Actually, yeah, the Anjali is right. So, for uniformly, we can talk about this, not point wise. But yeah, that implies point wise. But still, it is not okay. Because x equals to 0 is not problematic, right? If we put x equals to 0, then the series is 0 only, and that converges 0. Okay.
The doubt I had when you mentioned
Yes,
that
yes,
point
yes, yes,
itself, but I
yes.
did not want to disturb you.
No, no, no problem, no problem.
Full flow
No,
of
no.
thought.
Whenever yeah, you feel something wrong, okay, so you ask, okay. Uh, Actually, I am also studying this time, okay. So this course I studied in my masters, okay.
Mm.
So yeah, but these are very basic thing. So yeah, just yesterday I wanted to solve it, okay. Whatever comes in my mind, so okay, no problem. I will see it. But okay, diverges almost everywhere. That is good. This incorrect, but yeah, if we put x equals to not cos is there, this sine. So okay,
Sir, I found the formula for the sum. It
yeah.
turns out to be sine nx by 2 times sine of n plus 1 x by 2
Okay, let's tell again.
times, okay, this is multiplied by sine of
Sine of
n plus 1 x divided by whole divided by 2
okay, and divided by
divided by sine x by 2.
actually I just told you, right? So that's
Yeah, the
why this
denominator.
is not bounded na. X equals to 0, if you put x equals to 0, this is not bounded.
Yes, sir.
Yeah, but okay, means from here I like I cannot find any wrong from here, okay, using Dirichlet's theorem. But here just what Rovi pointed, so like this series at x equals to 0, it should be converged. So this is the problem. So yeah, I know the series, the like the sum. So whenever you put x equals to 0, x equals to 2 pi means x equals to pi, right? Sorry, sine pi, that is 0. 4 pi sine 2 pi, that is 0, and so on. Okay, so that's why this is not bounded for this, and except this you can put anything, and always this is bounded because these two are bounded. Sin nx and sin n plus 1, these two are always bounded, so modulus is always less equals to 1, and but this is not, this denominator part is not, okay, always. So that's why, so when x equals to 0, 2 pi, 4 pi, okay, sorry, I got your point. But okay, I will see it later, okay. uh, Sorry, sorry. The convergent point wise almost everywhere. Okay, why point wise is there? Maybe it is if it is uniformly, then true.
So
Okay,
point-wise would be true for all the points in this minus pi to pi, including 0. Maybe that's why. But uniformly on the whole interval won't hold true
yes,
because the
yes, yes,
Dirichlet test is failing at 0.
yes, you are right. So in question, like we should mention this is uniformly, right? Then this is true, and yeah, maybe like I don't know, like you can check your assignment 0 problems, okay, and their solution have like they whether they provided solution for assignment 0.
Yes, sir. They later on correct the answers, whether we have marked the right answers or not.
Okay.
Hmm. Immediately it will show.
Yeah, no, answer means like answer also they submit, right?
Yeah, no, they don't submit. You give the answer, select it. Once you submit, it will show
Okay,
whether
just check
correct or
whether,
not. Correct or not, it will show.
okay. Please.
Only after the time period, though, like after the 4th of February, they will show whether
No,
your
madam, that is for the real assignment. This is zero
It is
assignment.
zero assignment.
Oh,
Zero
real
assignment,
assignment.
it is
Okay.
not
Yes, yes.
evaluated.
Yes,
It
Yeah,
is
and
yeah.
real
immediately once
assignment
it
I
is
will
shown.
like I won't solve. Okay, so I can help you, but I cannot solve.
Immediately it will show.
Yeah. Okay. So you can check which options are correct. I did not check actually. Okay.
Yeah, I have the answer with me.
Okay. So which
I
one?
can tell. Huh?
Which one? Can
Yeah,
you
yeah,
check?
I will tell, sir.
Okay.
Just 1 minute. Just give me.
Okay. Okay.
Answer is very clear. Whatever you have written is correct.
I only see option true.
Yes.
Okay. Okay. And
But
in
there,
question,
I
can you
have
check
checked with
one
the,
thing more?
I have checked with this thing, no? C option, whatever is there, reason is given also. Hence, point-wise convergence everywhere, not just almost everywhere. In fact, everywhere C is true. It converges point-wise almost everywhere on minus pi pi. Actually, everywhere. So
I-
D is false, it converges everywhere. D is false since it converges everywhere. Actually, it converges everywhere.
Okay. Okay. Okay.
That is the logic given.
Okay. Okay. Then it is correct. Okay. If you
Yeah,
take.
we are saying that zero also it was
Okay,
converging.
okay. So, yeah. So actually, almost everywhere is not used. Okay, then. Okay. So, yeah.
Still, that is the answer. C.
Okay, okay. So this is true. Like converges point wise, everywhere. Not almost everywhere. And
Hmm.
okay, okay. So option C is correct, but like option B is not correct. Any reason is given?
Yeah, I can tell you the reason. Not that they have given there, I have found from some other source. I'll give you the reason for the everyone, every reason.
No, no. I am asking for converges absolutely or not.
Yeah, I will tell that. Just 1 minute.
No, I think like it is not absolutely because uh,
See, first one A is false.
okay,
B is also false because not absolutely convergent.
yeah,
Is reason. C is true because converges pointwise everywhere. That is A dot E or something everywhere. Yeah,
almost everywhere. That is
D
almost everywhere.
almost everywhere. A dot E.
Hmm.
False. D is also false.
Okay,
So A is false because no absolute uniform convergence.
okay.
B is false because not absolutely convergent. C is
No,
true.
no, no. Actually, yeah, yeah, yeah. So actually, so yeah,
I
they are.
think it's P series. When you take absolute value, it's equal to 1 over root n. So you can apply the P series test.
No, no, no. Yeah,
P will be half,
I got
right?
it. I got it. But if you
Not
take
absolute.
absolute value, if you take absolute value, then mod sin nx is not one always, right? Yeah, see, for a particular value of x, if you put x equals to something like what should you put? Like x equals to n, sorry, pi, x equals to pi, if you put, then sin n pi is your minus 1 to the power n, and in that case, this is not absolute. Okay, because modulus is 1, right? Yeah, see, you can show it by this way, like for x equals to pi or minus pi. Okay, no, n pi is always 0. Sorry,
See, n pi, no, not always zero. N pi means, sin pi is
no, no, no,
zero.
sin n pi 0, 0, sorry.
Sin n pi
So
is zero.
sorry, x equals to, you take pi by 2, x equals to take pi by 2, then you are getting, right, x equals to pi by 2, then your n pi by 2 divided by root n, this sum n equals to 1, so this is n pi by 2 is minus 1 to the power n, right?
Yes.
No, not
N
always.
plus 1.
uh,
Yeah, sin pi by 2 is 1.
No, 2 pi.
Sin 3 pi by 2 is minus 1.
No. That is not always minus 1 to the power n plus 1. Sorry. Because if you put n equals to 4, then this will be sine 2 pi. Okay, so that is 0. Okay.
No, n is odd only. If n is odd,
Yeah.
So 2n plus 1 pi by
but
2.
n is odd, that will apply. N is even, it will be 0.
Yeah. No. What should I put? So I'm like asking
Say
what should I
2k
put?
plus 1. N equal to 2k plus 1, suppose. Then it is minus 1 to the power of 2k plus 1.
Okay.
Minus 1 to the power minus 1 or 1.
No. X equals to what? I should put
2k plus 1.
not x. I am saying about x.
X is pi by 2.
Pi by 2, but the whole series I cannot study right further. Okay, I'll see. Okay, so we don't like we should not waste time. Like okay, I will see. No problem. Okay, I will check it. It is absolutely not. It is not absolutely convergent. I know, but okay, I have to check it. Okay, so I think last problem, question 5. So in next day we'll start the assignment from our main like main course. So these are assignment 0 the problem. Okay. So sometime you need to calculate the residue of a complex valued function. The residue of cos z by cos hyperbolic z at the point I pi by 2. Okay, is
So, what is the definition of residue? We have to see.
do you know what is the definition of residue?
I don't remember now, but I heard this word.
How to calculate residue? Okay,
First,
so
what is
like if you have you know about pole,
huh?
pole singularity pole.
Yeah, pole, yes. 1 by z minus 1, z equal to 1 pole.
1 by z minus 1, so z equals to 1 is pole, right? So basically see, okay, so fz is a function. Okay, and if z equals to z naught is a pole if limit z tending to z naught fz is infinity. Okay.
Mhm.
and
Yeah.
and the residue is f at z naught. This is limit z tending to z naught z minus z naught fz. Okay, this is the formula for residue, but here we will use some like special properties to find because these are special function, right? Cos hyperbolic z, cos z.
Yes.
Okay, so you cannot find easily. Okay.
You can write cos hyperbolic in terms of exponential function.
I can convert, but so like maybe I cannot get any benefit. Okay, to like I think so we have to use one formula. Okay, so cos hyperbolic z. So see first this is the function fz, right? So at which so cos z is analytic, right? Do you know about analytic function?
Yes.
So
Cos z is analytic.
cos z is analytic. So you
Yes.
have to check only the zeros of cos hyperbolic z. So these are poles. So the poles of fz are given by the zeros of cos hyperbolic z, right?
Yes.
So
It
Anjali,
will
do
be,
you know complex analysis?
yes, a little bit, yes.
Yeah, so I'm asking for Anjali.
Yes, sir.
Okay,
Sort
so
of.
yeah, just you know these basic things, right? Pole,
Yes.
residue, yeah. Yeah, so when this cos hyperbolic z is 0, so
So
this
e
is
to the power of iz plus
2n plus 1 pi by 2. Ha, yeah, so that's how like e to the power z.
plus e to the power of minus z by 2 equal to 0.
Okay,
So,
yeah.
so e to the power of z equal to
Uh,
minus 1 by e to the power of
so
z.
e to the power z equals to minus e to the power minus 1 by z, minus z.
Uh, so
Okay.
you can bring one side this. So e to the
Uh,
power of z into e to the power of
no, actually you have to do
e to the
like
power of
this.
2z equal to
E to the
minus 1.
power z plus 1 by e to the power z equals to 0. So e to the
Uh,
power 2z plus 1 equals to 0. So e to the power 2z equals to minus 1. So
yes, there also you are getting same.
yes, yes,
That,
yes.
so it is a complex number.
Yeah.
Again, z 2z is a log minus 1 to the base e.
So minus 1 is e to the power what? Can you tell
E to
me?
the power of I pi, huh? E to the
Uh,
power of I pi.
no, I 2n plus 1 pi
Okay, okay,
minus 1. Okay.
general solution.
So z equals to I 2n plus 1 pi by 2.
Okay, okay.
Got
That's
it?
what you have written there. Yeah,
Whatever I
immediately.
have written there.
Uh,
Okay, n belongs
correct.
to z. Okay. So see, if you put n equals to 0, then I pi by 2 you are getting, right? So we have to calculate I at I pi by 2. We have to calculate the residue at I pi by 2. So n equals to 0, you are getting I pi by 2. Okay.
What?
So, no, no, I am saying you have to find the residue of fz at I pi by 2.
Mm-hmm.
Okay, so of course this is pole. Okay, so because you are saying, right, you are seeing like you are like you check
Yeah, n equal
this
to
I
0,
pi
it
by
is
2
I pi by 2.
is pole, right? And this is also simple pole
Yes,
because all are simple, right? So
yes,
this no, does not appear twice. Okay,
yes.
yeah. So simple pole. So I am claiming I pi by 2 is a simple
Oh.
pole.
Mm.
So once you have a simple pole, so you and fz is like gz by hz. Okay, gz by hz. So you can like you have one special formula. So for to calculate residue, I pi by 2 is basically, so this is what, cos z by cos hyperbolic z.
Yes,
Residue is nothing but cos I pi by 2
correct.
divided by this derivative. Okay, so the derivative is cos hyperbolic z at z equals to I pi by 2. Okay,
Mhm.
so for this basically we used the residue of f comma z naught is g of z naught divided by h dash z naught. Okay,
Mm.
and see cos cos I x equals to I time cos hyperbolic x. This is the formula. So you can, it's a simple, by simple computations you can check. Okay, so and sine, okay, I'm checking. So this is I times this is I times, so not I actually, sorry, uh, Only not I. So only cos hyperbolic x. So cos hyperbolic, sorry, cos hyperbolic pi by 2 and divided by what is the derivative of cos hyperbolic z? This is sine hyperbolic z, right?
Sine optical.
Sine hyperbolic
Sine
I pi
hyperbolic.
by 2, and this is just I times sine so sine hyperbolic I pi by 2 is I
E to the
times,
power of pi
for
pi by
cos I is not appearing, for sine
2. E
I
to the
is
power of I pi by 2 minus e to the power of minus I pi.
what?
In terms of exponential, you can write
Yeah.
in case of doubt.
So this is I time sine pi by 2. So I and I, so I square, this is minus, so minus I cos hyperbolic pi by 2. So this is the answer.
So last question.
Yeah, this was the last question. And okay, so from tomorrow onwards, like I will solve like some problem which will help assignment 1, 2 and so on. Okay, so what is the deadline of your assignment 1 problems?
4th.
Fourth Feb.
Oh, so yeah, I will take the next class like on 30, sorry, first April. Okay, 1st April. Okay, so no problem. You solve. Okay, if you have any doubt, so actually I cannot give the exact solution to you, but I can help you. Okay, and please see all the lectures. Okay, try to see all the lectures. Professor like has like described everything very well. Okay, and please see all the lectures.
Sure.
Yeah.
Yeah.
Okay then. See you at next class. Okay.
Yes. Thank you very much
Okay. Thank you.
Thank you, sir.
for
Thank
your
you. Yeah.
time and thank you.
Thank you.